So we want to continue.
Mm-hmm.
We did warm up, right?
Mm-hmm.
Okay, so we did fifth. We finished. I think there's one more left here. Okay, equations. Let's trig equations. Mm-hmm.
There's nothing showing on my screen.
That's right. Nothing
Mm.
is showing because I didn't share it.
Okay.
Okay, let's.
Would we do the same thing as before, or do I make one side equal the other?
One side. Uh, what do you mean? One side equal to the other?
Like 3 sine squared x equals cos squared x? I don't know. I don't understand what it's asking for.
So we need to find x for which. So it's an equation. So we need to find value of
X.
That's right. Let's try to do it. So we're given domain, right? So our domain is one rotation, right? So now we want to solve 3 sine square x equals to cosine square x. Okay, so what do you think?
Well, minus cosine on both sides.
Okay, let's try. Minus cosine square equals to 0. Okay, what will be next step?
Cos 2a equals cos squared a minus sine squared a. Oh, that's sine squared minus.
But it's not cos 2a, it's squared, right? But we have squares here, right? So we can try to make it to look like quadratic equation, right? So what is cosine squared? It's 1 minus sine squared, right? Equals to 0. Now we open brackets plus sine square x equals to 0, right? And then 3 sine squared x plus another sine squared x will be 4 sine square x, right? And this negative 1 we can move backwards, so there was no point to move it. But it's not, it's not a mistake, it's just extra work. So there was no point to move cosine square x. So 4 sine square x equals to 1. And then what? Sine square x equals to 1 over 4. Right?
And then square root that?
Yeah, and then sine x equals to square root of of 1 over 4, which is half, right? So now tell me sine of what angle equals to half?
I do sine inverse, right? Of 1/2.
Yes. So it's 60, right? 30.
I have to do radians, right?
Yes, because it's our domain is in radians, so the answer should be in radians.
Okay. Well, I got 0.5236 in radians.
But okay, let's do it in degrees. So in degrees, that will be 30 degrees, right?
Here, 1/2. Yes.
30 degrees. So 30 degrees in radians is pi over 6.
Wait, I would do 30 divide 180, right?
Yes.
Yeah.
So pi over 6. Now, are we good?
So
Yeah.
I would do 30 degrees times times pi over 180.
180.
But 30 divide 180 would be.
So you simplify. You don't convert to decimals, right? You just simplify a fraction. So you have 30 pi over 180.
Okay, I see. I got it.
So it's pi over 6.
Yeah, yeah.
Okay? So, but we know that square root of a number gives us two answers, right? So it will be plus minus half.
So I would do plus minus pi over 6.
Let's think. Your answer depends on your domain. So our domain is circle. So now we have to think, right, on this circle where sine equals to plus or minus negative half. So it will be here, right? We said this is pi over 6. It will be here, right, in the second quadrant. Are you following?
Not the second quadrant.
Why? This is second quadrant, right? Sasha?
Yeah.
What's...
But no, I just understand the angle in pi over 6.
Oh,
I mean, in the second quadrant.
It's here, right? Pi over 6.
Yeah, I understand that.
So what will be angle in the second quadrant that has reference? So you work with reference angles now, right? So reference angle is pi over 6. So in the second quadrant, it will be, or if it's easy for you to think in degrees, so we know that pi over 6 is 30 degrees, right? So reference angles of 30 degrees in the second quadrant equivalent to 150, right?
5 pi over 6.
5 pi over 6.
Mm-hmm.
That's right. And then third quadrant, reference angle of 30 degrees, it will be 7
pi over 6.
7 pi over 6. And in the fourth quadrant,
not that. 3.
so it's 11.
11 pi over 6.
11 pi over 6. So you have 4 answers, right?
But
yeah.
So it's any pi over 6 in that domain. I just don't understand the plus minus part.
Yeah, because a square root of any number gives us 2 answers, right? Positive and negative. Mm-hmm. So let's say square root of 4, right? It's plus minus 2.
Mm-hmm. But then why do we have 4 answers? Are they all plus 1/2?
No. So sine, right? Sine is positive in first and the second quadrant, right? So this is half here. This is half. Sine corresponds to y coordinate, right? So here sine will be negative half, and here it will be.
Okay, so it's okay. Yeah, I understand now.
Right, because sine it's a y coordinate, right? So y axis. So y is positive in the first and second quadrant, and negative in the third and fourth quadrant. We good?
Yes.
And we can check, right? Let's pick up pi over 6. Let's see. 3 times sine squared of pi over 6 equals to what? Pi over 6 is half, right? Half squared is 1/4. 3 times 1/4 is 3/4. So far, so good?
I don't understand why pi over 6 squared and you multiply that by 3. Why don't you do 3 times sine of 1 over or whatever pi over 6 squared is?
Yeah, this is what I did. So sine pi over 6 is what? Half. So half, then we square it, right? Half squared. 1 over 2 squared will be 1/4.
Yeah. So then it's 3 times sine of 1/4.
No, not sine of 1/4. Sine of pi over 6 equals to half. Right? And then you squared both sides. We have sine squared, so it means we need to square the result.
Okay.
Which gives us 1/4.
And then the times 3?
And times 3. Yeah. 1/4 times 3 is 3/4.
I think I get it. Okay.
Okay, so that's left side. So let's try right side. Cosine squared of pi over 6. Okay, so cosine of pi over 6 will be square root of 3/2. And then we have squared. We squared, and what do we get? We get square root of 3 squared will be 3, and 2 squared will be 4.
Okay, that makes more sense.
So you just check your answers.
Okay.
Okay, next question. So 2 sine So we have same domain, right? So we have domain of between 0.
Would I do 2 times 1 minus cos squared x and then the rest of the equation?
We're doing second one, right? 2 sine squared plus 3 cosine x minus 3. Is it? Yeah. Okay. 2 sine square x plus 3 cosine x minus 3 equals to 0. Okay, so what can we do here? What do you think?
1 minus cos squared x instead of sine squared x?
That's right. Okay, and then
Multiply.
by 2, so we open brackets, plus 3 cosine x minus 3 equals to 0, and we open brackets, minus 2 then we combine like terms, so it will be negative 2 cosine squared x plus 3 cosine x, 2 minus 3 minus 1 equals to 0. And what do we have here? We have quadratic equation, right? That's we're trying to solve. So you can replace cosine if it's easier. You can cosine x, let's say, equals to whatever, y, or any letter. It's not necessarily, but if it for visualization.
Yeah, I use the letter instead.
Okay, so let's try to solve this quadratic equation. So it will be negative 2m squared. So it will be 2 plus 2m plus m minus 1 equals to 0. Then we factor negative 2m so we have negative 2m plus 1 and m minus 1 equals to 0.
From my way, would I find that they're
No,
wrong?
you'll have two solutions as well, right? So.
But what does the negative mean on the outside? It doesn't matter?
It doesn't matter. Yeah.
Okay.
You just factored, right? Negative, because we have two factors. You just factored negative sign. In the way I did it, so you'll have m equals to half. Yeah. So two solutions. Okay.
So that would make the x's equal to 0.
Cosine equals to 1. Okay, 0. And
x is a half at pi over 3.
Pi over 3. And where else cosine is positive?
5 pi over 3, I think.
What is it?
5 pi over 3.
5 pi over 3. So it should be, 300. 5 pi over 3.
Would it be okay for me to leave the 0, like 0 degrees, or would I just
No, it's just 0. 0 pi.
Okay.
Not degrees. Is it 8? Let's see. 0. So if it's 0, then sine at 0 is 0, right? Cosine at 0 is 1, so 3 times 1 is 3, 3 minus 3 is 0. Okay, works. Pi over 3. So pi over 3, sine of pi over 3 is, what is it? Square root of sine square root of 3 over 2, right? Square root of 3 over 2 squared times 2 plus cosine of pi over 3 is half, so it will be times 3, so it will be 3 over 2 minus 3. Let's evaluate. So it will be 2 times 3 over 4 plus 3 over 2 minus 3. So we have 3 over 2 plus 3 over 2 minus 3. So 3 over 2 plus 3 over 2 will be 6. 6 divided by 2 is 3. 3 minus 3 is 0. Okay.
Times 3. I'm not understanding the 0 one, how it's calculated.
So sine of 0 is 0. Right? 0 squared is 0. And then 2 times 0 is 0. Right? So this term is 0.
I get. Just
and then cosine of 0 is 1.
X is equal to 0. Okay, 1. But, or do we have to say pi over 2?
No, cosine of 0 is 1. Not pi over 2 is...
When x is equal to 0...
Cosine of 0 equals to 1.
Cosine...
So cosine is x coordinate, right? So if this is your terminal arm...
x is at 0.
Right? So it means our point is here. Our terminal arm is here. This is our terminal arm. Right? So
but at that point, isn't x equal to 1, not at 0?
X equals to cosine of... So in this... So yeah, I see. Cosine theta. Let's think about, like, this is not coordinate. This x is not coordinate. This is angle. This is not... This is not coordinate in the sense that you think about coordinates, right? It's not x and y. So in this case, it's a angle. It represents angle of the terminal arm. Okay, so it's not coordinate, right?
Yeah.
So yeah, it should be like theta, right? So what we more used to.
Okay.
So they put x to show that it's unknown value, right? So it's an equation, and we need to find unknown value. That's okay. Next one.
Can I do 1 over cos x on the secant side?
Yeah, so we have same domain.
And then I would multiply both sides by cosine x?
Yeah. Okay, so did you get quadratic equation? So we have 2 cosine x.
At the end I got 2x minus 1 and x plus 1.
2x minus 1 and plus 1. Okay, so first set of solutions will be cosine x equals to half. And cosine x equals to negative 1. So cosine x equals to half, where?
Pi over 3.
Pi over 3.
And 5 pi over 3.
And 5 pi over 3. And from here, cosine x.
0.
No,
No,
0.
pi. It's equal to pi.
Pi. So I'm gonna put them in order. Good? Okay, next one.
I know that cosecant squared minus cotangent squared equals to 1, but I don't know what to do with the 2 in the front of cotangent.
Okay, let's see what we can do. So cosecant is 1 over sine squared x. Right?
But can't I use the formula 1 plus cotangent squared equals cosecant squared?
Probably. If you can use formula, we're going to use formula. Which one?
1 plus cotangent squared equals cosecant squared.
Yep, we can use that formula. Let's write it down. So 1 plus cotangent equals cosecant. Okay, let's first write the equation. So we have cosecant squared x minus 2 and you mentioned we can use, instead of cosecant square, we can use 1 plus cotangent squared x minus 2 cotangent squared x equals to 0. And then what do we have? We have negative 2, we're going to combine like terms, right? 1 cotangent minus 2 cotangent will be negative cotangent squared x equals to negative 1, or cotangent squared x equals to 1, or cotangent x equals to plus minus 1.
Okay. And that would be at 0 and pi.
0, y 0 and pi.
Oh, cotangent, not cosine. Then x over y. Would it be anywhere where it's pi over 4?
Pi over 4. So how many answers we're going to have?
4.
4. So it's pi over 4, then 3 pi over 4, then what, 5 pi over 4, and 7 pi over 4.
Yep. This one might be hard if it's star.
Yep.
So I'm guessing tangent would have to be
what's it called, sine over cosine, or what I yeah.
Is it? Let's take a look at formulas, right? So let's first let's see what we have. We have tangent
We have tangent and sine.
Plus 2 sine x plus pi equals to 0. Right?
Yeah.
Okay, so what can we use? So tangent of sum of the angles, right? So we can see what is it equal to. We can replace this as tangent of x plus tangent of pi over one minus tangent of x
okay.
times tangent of pi.
I see what you're doing now.
And now, what is tangent of pi?
Tangent of pi
So
when y over x equals to pi.
Yeah, so it will be sine over cosine, right? So sine of pi is 0, right? So what is tangent?
Okay, so it's just 0. Okay.
Right? So it's a sine of pi over cosine of pi, right? And cosine of pi is 1, so sine of pi is 0, right? So this term is 0. What happens in denominator? So tangent of pi is 0. That means that this term is equals to 0. So at the end we're left with tangent of x over 1, or it will be just tangent of x.
Okay.
So all this expression turns into just tangent of x.
And then I would do the same thing to sine?
Yeah.
Or no?
Yes, sine of x plus pi. So we can use again formula. So sine a plus b, so it will be sine of x
Cos of pi
times cosine of pi plus cosine of x times sine of pi. And again, right, cosine pi is 1. So,
isn't it negative 1?
Negative 1, that's right. So then this will be negative sine x plus no, sine of pi is 0, right? So second term is out.
Oh, okay.
So at the end, we're left with tangent of x minus sine of x. So this is much more simple.
What I do now is sine over cosine, or
let's think. Sine over cosine. So what is gonna? Yeah, we can try. Yes. So sine over cosine minus sine x equals
Would
to...
I multiply sine x
Yeah,
by
then
cosine?
then we do common denominator.
And then would I multiply that common denominator on both sides?
Then we have sine x times cosine x equals to 0. And now what we have? We can factor sine. And we have 1 minus cosine x equals to 0.
So when it's the same denominator, I can just forget about it?
That's right. Keeping in mind that NPVs, right? So in case we get pi over 2, right? Answer. So we should mark NPVs.
Sine of...
So x cannot be equal to pi over 2 or 3 pi over 2. Okay? Because we have division.
But I'm confused on the 1 minus cos x.
Yeah, so what do we have here? We have sine of x minus sine x times cosine x. Are we good here?
Yeah.
Then we can factor sine, right? Because we have...
Out of the... okay.
So, and then we have product, and then product of two numbers equals to 0 when one of these numbers equals to 0.
What?
We have product.
Sine of x equals 0. Okay, got it.
Yeah, we have, because we have product now, right? Product of two numbers.
But
Yeah.
1 minus cos x
Equals to 0. So we have, so let's do first sine x equals to 0 when angle equals to what? At 0 and pi. 2 pi is not included, right? So 2 pi is not included because of their domain. Our domain is x greater or equal to 0 or less, strictly less than 2 pi, right? If we would have here less or equal, then we should include 2 pi as well. But because it's strictly less, then 2 pi is not included. Because
but then when it's less than and equal than 0, okay. Okay, that's okay, I get it now.
Right? If we would have equal sign here, less or equal, then we would have three answers. So and now, so this is first set, and second set is cosine x
equals to
1. So in this case, x equals to cosine
0 and pi. Oh no, just 0.
Not 0, it's pi over 2 and 3 pi over 2. Right? Cosine of 90 degrees is 0 and 270.
But I thought it says cos x equals 1.
Oh, right. Yeah.
Okay. So that would be 0, just 0.
Equals to 1. Yeah, but we already have it, right?
Okay.
Yes.
So then my answers would be x equals 0 and pi?
0 and pi. So.
Okay.
So we've done all the warm-ups, I think. We can
Yep. I'm writing it down right now.
Okay, tangent squared theta minus sine squared theta. It's the same as tangent. Okay, left side. So we need to. So tangent squared. Oops. Minus. So let's simplify. What
I
can
changed tangent into secant squared minus 1. Or is it not simple?
Okay. So we want to prove that left side equals to the right side. Okay. So let's see. So sine squared theta over cosine squared theta minus sine squared theta. Right? Then what do we have? We can do common denominator. Sine squared theta minus sine squared theta times cosine squared theta over cosine squared theta. So far so good?
I understand the sine over cosine, but what's the sine times cosine part?
Yeah, common denominator, right? Because
No,
here
no, I understand the left side, just not the right.
Okay, so what don't you what? So we do common denominator, right? Because we're here.
Oh, is this still the left side?
No, we're trying to prove that left side equals to the right
side. So we're just solving left side right now.
Right.
Okay.
Questions?
I'm thinking on what to do next.
So up to here, does it make sense?
Yes.
Yes?
Yeah.
100%.
100% because you take the sign out.
Yeah.
And then
Okay.
there's one
And then
square
what you
thing.
can do. So what is 1? What is 1 minus cosine square? It's right. 1 minus cosine square is
Sine squared.
it's sine square
Sine squared.
over cosine squared theta. Right? And then you can write it as 2 factors. Sine theta squared over cosine squared theta square theta times.
Times sine. Okay. And then left side equals right side.
And here's we get tangent square theta times sine square theta.
Yeah. Okay.
Okay, so now opposite, right? So opposite, you just do reverse engineering.
Do I have to solve the other side too?
Yeah, I think this is. It looks like what they ask here to do. So left side. So first we have to show that left side equals to right, and then right side equals to left. This is the proper way to do it.
Yeah.
To prove identity, because you have to show it both ways, not just one.
Yeah.
But both ways.
Okay.
Okay. So.
Yes.
Okay. We'll see you Friday.
Actually, I'm gonna be gone on Friday, but we're gonna have the next week Tuesday. I come in person from 1 to 3, right?
Yes. Sure. Yes. 1 to 3. Yeah.
Yeah.
Okay. Yeah.
Tuesday,
Yeah. Right.
Okay.
Okay,
Thank
Sash.
you. Bye.
Bye.